The first step in using AVA to deploy the pure elastic reference architecture is to create an empty Git repository. This Git repository is going to be associated with inventories in our AWX/tower installation, and it will be used to house both this reference spec that we're going to fill out that will create the reference architecture, as well as store information that we collect about the deployment once we're done. And that information will be stored both in Elasticsearch for visualization, as well as in YAML files in this Git repository, so that it can be safely checked in and we can track changes over time, so that we can catch any configuration drift that might happen and cause problems. So when we're looking at this file comes from AVA architectures. So after you create the Git repo, you would download the AVA architectures Git repo from GitLab. And inside of that, there would be different spec files. One of these spec files is for this pure FlashBlade Elastic deployment. And looking at this file, this one's already been filled out. It wouldn't be filled out initially. You need to give it some basic information like your FlashBlade management IP address, as well as an API token that you would generate either using command line or in the GUI. The inventory that you want to point at. This file system section would be if we were going to run Elasticsearch on a pre-created file system, so maybe we're installing it using bare metal, the bare metal install option, or the Docker Compose / Docker Swarm option, but we're not going to do that. We're going to use Kubernetes. Here's some information about S3 users, which we will use to create an S3 repository that will be used for backups through Elasticsearch. Down the Elastic section, we have Elasticsearch and Kibana. We have information about what inventory to use as well, what version to install, and then here's where we pick the install source, so that's important. It could be vendor repository, which would be Elasticsearch's repository and would install bare metal. Offline RPMs, which would also be bare metal. Docker Compose, which would also work with Docker Swarm. And then last we have Kubernetes, and we selected Kubernetes. We put our port information, how many nodes we want. Some of this information isn't actually going to be used since we're doing it with Kubernetes. Here's our S3 bucket that we're going to create and the endpoint. And then we also, this is important, we're defining the storage class as pure file. So it's going to use Pure's PSO to create the volumes for the containers. And then we did something similar here with Kibana. So once you fill this all out, you copy it to the appropriate directory, which we've already done up here. So architecture specs, Pure FB Elastic. And then we will jump over to our AVA Elasticsearch node, which we've already deployed AVA. We're going to go to the deployments dashboard, and this dashboard will show existing deployments that we've already done and some information about it, as well as have buttons on the left here that allow us to do some things. The next button that we would use, the next task we would do is clicking this button, Load Architecture Spec, and that will take that YAML file. It will download the Git repo, take that YAML file, manipulate it a little bit, and use the output to update the variables in AWX/tower in the inventory for the machines that we're going to deploy to, and that way it can pull those variables and use them in our playbooks as it deploys this reference architecture. We've already done that though, so I'm not going to click that button. We are going to click, so after that's been uploaded, we would click the Put Pure Elastic Reference Architecture, which is going to run a multi-stepped workflow that will do various things. And it will reduce the complexity of deploying this environment by quite a bit, and you'll see the different steps it's doing, and then of course inside of each one of those steps there's many more subtasks. So first thing, I'll show you that our Kibana server is not actually up right now. It was up, it's down, and if we look at Kubernetes, we see that we don't have any pods deployed. So now that we've confirmed that, let's go back to deployments and let's launch our reference architecture. This is going to launch the workflow and then redirect us to AWX/tower so that we can see the workflow running. And there's various things that it's going to do. It's going to install the pure PSO Kubernetes plugin, and if necessary it will install Helm as well, and then load the charts and generate the file with the API key and the management URL and additional information about the FlashBlade array, and use that to register the plugin with Kubernetes so that it knows how to create those volumes for us. Then it's going to create the S3 information needed for the snapshot repo in Elasticsearch. And it's almost done doing that. And then the next two things it's going to do is install Elastic on Kubernetes using Elastic's ECK. And then it's going to install Kibana using ECK. And then lastly, it's going to create a record of this deployment in Elasticsearch. And that is where this information here comes from, is that last step. So while that is going on, we can talk about some of these dashboards. So this first dashboard, let's change the time frame here to something a little smaller so it makes more sense. This dashboard is a performance dashboard. It also has some information about, these are from our bare metal installs actually, but there's we're actually parsing the Elastic and Kibana configuration files. The main purpose of this dashboard is performance, so we're getting per client performance from the pure FlashBlade and putting that right above the Elastic Node ops so that we can kind of compare those two directly. We also are pulling additional information about Elasticsearch's performance that are important in an Elastic environment, like indexing, query time. We have CPU as well as Java heap information and garbage collection. And then the last thing on here, visualization-wise, is FlashBlade alerts, which we don't have any for this time frame, so we're going to change this back. And you can see that we are querying the API for alerts on the pure FlashBlade. And then the last piece on this dashboard to talk about is the buttons on the left. We have a button that will collect all information about Elasticsearch. That's Elasticsearch, Kibana, Logstash. We have another one that will do the same thing for the Linux operating systems that are supporting it. So in this case, it's going to be the Kubernetes nodes. And then this last one will collect all of the information that we can about the pure FlashBlade system that's supporting all of this. So that's that dashboard. Let's take a look at our workflow and see where we're at. It's on the Elasticsearch phase, so let's take a look and see what's going on there. And we can see that in Kubernetes now we have the pods that are being created, so pure ECK, AVA, Elasticsearch, and there's 3 of them. We have our storage claims that are being created, and you can see that these persistent volume claims are being created with the pure file storage class. And what that's doing is actually allowing Pure to create the volumes for us. So if we look now in our Pure UI, we can see there's 3 new volumes that are created here with these UUIDs, and those are actually what our Elastic containers are running on now. So it's going to finish up with the Elastic install and move on to Kibana. So while it's doing that, we'll look at another dashboard. This dashboard is pulling all the information about the Kubernetes and ECK. So what we're seeing here is the persistent volume claims, like I talked about, showing that it's using the pure file class and it's using the pure CSI storage provider that come from the PSO plugin. We can also see our pods running here, including the Elastic operator. This is just showing all the jobs that we've ran, both getting and putting configurations in Elastic, and then this is showing the status of those down here. These buttons on the left are if we wanted to push individual configurations after this entire architecture has been created, although you could just run the whole workflow again, which is probably easier, which is why we have the pure Elastic reference architecture here again. But if we just wanted to update some Elastic configurations, Kibana, Logstash, or update some file systems or S3 information, we can do it directly from here. And whenever you click these buttons, it's going to pull that Git repo down again and look for any changes and use the YAML files that are stored there as the inputs to these. This next dashboard is tracking configuration drift. We have 3 different sections that we're displaying right now. We're displaying pure Elastic and Linux configuration drift, and we see in the last hour we don't have any Linux configuration drift, and that's why this shows a 0. These other 2, we do have configuration drift, which is why they're a 1 or a 2. Right now they're a 2. 1 would be 1 item has drifted, and a 2 means 2 or more items have drifted. And if we look at some of these items that have drifted, as an example, file systems here have changed. So it looks like 3 new file systems have been created, which that's probably from us running our deployment on the FlashBlade. And once again, we have the ability to collect all of our information using these buttons on the left. If we thought that maybe there was a problem and we wanted to see if it had been resolved and that drift is gone, we could run these again. And that brings us back to the deployment page. So if we look at deployments, we have some different things we can do. Like I said, we can put the architecture. We can also completely remove the architecture, and that will remove all components, including the pure components. And then we can also create a snapshot once this is all done. Because we are setting up Pure with object storage as part of this and registering that in Elasticsearch so that snapshots can be used to back up Elasticsearch to the Pure. It looks like we're not seeing our snapshots here because it's been a while, so we're going to increase this a little bit. And we can see that snapshots have been taken. Those would, likely be put on a schedule and integrated with lifecycle management. But if you wanted to create a one-off snapshot or force it to just run its scheduled snapshot, you could do it here. We're also, like I said, parsing the configuration files. So here's the Elastic configuration file, the Kibana configuration file, and JVM options. And these are just some examples. And then at the very top, you can see our deployments that we've done. And it's telling us, that we installed the Pure Reference architecture, and we installed it. Install source was Kubernetes, and the version is 7.6.2. So let's go back, see where we are on our installation. It looks like it's still installing Kibana. So let's look at Kubernetes and see what it's seeing. should shortly see the Kibana container or pod start to be provisioned. And then shortly after that, the networking will be configured and we can get to the Kibana UI. So each one of these steps has been greatly simplified now. You no longer need to individually, install PSO, configure ECK, and then deploy it. You get all of that in one workflow, and it's monitored, and the configurations are tracked by default once it's complete. And now we can see the Kibana pod is running, the Kibana service is up, and it just created the record of our deployment as well. So it's done, everything's green. So we should be able to refresh our Kibana page, and it's completely up and running.